definitely it will be advantage for you.
Hello, good evening. So I see a message today, no session, but it's from someone else.
When you saw that message?
10:48 a.m. No, sorry, take it back. And also, one thing is not clear from pre-order and in order, how to derive post-order.
Hello.
Yeah.
Sorry, Vishnu, you were not audible. Like you can repeat whatever you were saying.
Ma'am, one thing is not clear from pre-order and in order, how to derive the post-order.
Okay.
I mean, I remember one time you said that probably the question is wrong.
Question is wrong?
No, means, see, if the sequence of number has to match the tree in order for the question to work. So, I mean, I took another example and then there it works, but for the given example, it doesn't work. So, I mean, can we take a fresh example and then see how
Yeah,
to
sure.
post order from the pre and in order? Yeah.
I'm not sure why is it not opening. Let me just check it again. Stop sharing.
It's opening for me. You can see.
No, actually, Microsoft Whiteboard is right now running very slow. So I'm just saying about that.
And one suggestion, ma'am, actually last person who messaged in Telegram today, no session. Can we delete so that people are not confused by that?
Yeah. Actually, there is going on a Zoom issue today. So probably that's why we were not able to get connected to the session. But right now it has worked, luckily. So that's why. So admin just messaged and then we got this, like it started.
Thank you.
Okay, so we will start from today. The coding part, we'll write that. Let's just I'm not sure why this whiteboard is running so low today or so slow today. Okay, fine. Till then, we'll discuss. Did anyone try the code for post order, pre-order, and in order one? Like you have been given pre-order and in order, and you need to find the post order. I heard Vishnu's doubt, but instead of that, does anyone did that? Can do, okay. And the first one is BST. Did you wrote the code for that? No. Okay, and the path one also for sure you guys must not have done it. Okay. Issues. And I'm not sure why this whiteboard is also giving me so much problem.
I mean, in the meanwhile, you can just start with IDE.
I have started the ID, but I just want to see why this whiteboard is not working at all. That's the problem. Because it never takes that much to load.
Yeah, my screen, if I have a screen share permission, then I can show if that helps.
It won't be helping because there is always a lag when you take the remote access from someone and do some things.
Okay, okay.
So that's a problem. I can't. I'll just try to open some other whiteboard and see what happens. Yep. And now it's not opening. Are you guys able to see my screen?
Yes, ma'am.
Okay. So we are on trees. I'll just create a new one. Do you want me to do the in order and post order one? Yes. So for that, you can tell me what's your doubt?
Like theoretically understanding, I've still not got how this, because my understanding is when we do pre-order, it'll go all the way till the very bottom to the left. But in this example, in pre-order, the first element is the root. So that one I could not understand.
Who said you that when we are writing the pre-order, it first go to the very bottom?
Oh, okay. So, I mean, I was going through one example in the whiteboard.
Do you have the understanding of pre-order?
Yeah, it'll keep going left first.
Acha, what is the formula for pre-order?
Left, then the data, then the right.
Yeah, right. Okay. If it has no left, then?
Okay, then it will start with data. But if there are some lefts and left and left, then it will start from the leaf of the left
Okay.
side.
And
That's my
what about in order?
It will be start from the root, which is the data root, and then left and then right.
So you are confused between pre-order and in order. In order, it's like LDR, that is left, then data, and then right. Okay. That's why I told you yesterday that in the in order, you write the complete left tree and then root node and then the right side. That's why you get a sorted array when you write the in order of any tree traversal of a BST. Getting this?
No, sorry, I didn't get it.
You have forgot the pattern for pre-order. That's what I'm saying. Pre-order pattern is first you have to print the data, then you go to the left hand side, and then you go to the right hand side.
Okay.
For in order, it's like left, then data, and then right. Make sense?
Yeah.
Yeah, that's the thing which you are missing, and that's creating a problem.
Okay.
Got it?
Yeah, I'll check it. Yeah. Thanks.
So guys, please practice, otherwise these things are happening. I'll just copy. Are you sending something in the group, Vishnu?
Ma'am, in the one of the old class, which I was like basing my thoughts on, I just put one picture, and in that yeah, there was an example where you showed that pre-order was left, then data, then right. So the last image.
Oh, okay. Has I made it wrong? Just give me a minute. Let me double check it. Sorry guys, my bad. Actually, Vishnu, it's DLR and then LDR and then LRD. I guess I have switched the two things. And I've wrote them accordingly also, but it's wrong. Please correct it right now. Thanks, Vishnu, for pointing that out.
Oh, okay, okay. I mean, thank you for sharing, because I was also not following on Google. What is it there?
Yeah, so now is it clear?
Oh, yes, now I will revise everything.
Okay, great. So basically, you have been given an array. Okay. Now, what is your doubt? Pre-order and in order. Can you tell me?
Yeah, how to derive the post-order sequence from theoretically first, like pre-order and in
See,
order.
basically, what will I first do in this question? I don't have any pre-order and in order ready with me so that I can make a post order. So first I am having a tree, like I'm having an array. I made a tree out of it. Okay, that's my first step. It's not it's not something which you should be bothered about, because in the question, it will be straightforwardly given to you. You have been given an in order array, you have been given a pre-order array, and then you need to fix the things. Clear? So you need not
Yes.
worry about it. But right now, if we have to do this question, we should have the in order and pre-order correctly configured, right? So that's why I'm writing that piece of code extra. Okay, now after this, I'll just store my pre-order in the array, and I'll just call my pre-order. Here I'll pass root. Similarly, I'll just have my in order, and here I'll get in order and root. Trees are going really very slow. I just want to make it a little fast. Okay, so here, better you can pass everyone clear. Now I'll be storing my, it's simple. I need to store my data first. So, sorry, I need to call the left in the in order, right? So I'll just call in order. And here I'll be passing root, not left, comma, in. Then here I'll be storing in of, I should pass the index also. Here I'll fill in of I equals to root dot data. Then just do the same thing for right. And if at any point your root is equal null, return. Same thing for pre-order. Clear, everyone? So now we will be getting our pre-order.
Ma'am, 1 second. If you go to pre-order, both are same in order. One thing I observed in pre-order, Could you please go to that method, pre-order method?
Yeah, I
Why
got
I'm
it.
asking
I got
some
it. What you try to say. This thing is, my bad. First, the data should be stored, and then the left, and then the right. Yeah, that's correct.
thing.
That's it, right?
Yeah. Okay.
Yeah. Okay. So we have in order, we have pre-order, and now we need to work on how to get the post order. As per the, like, first we should know what is in order and for post order, right? Yeah, correct. Let's print it. It is it is printing wrong. We are modifying I value at both the method. Um, I don't think so. That should be an issue at line 20. Yeah, I got that. Let's just keep it as an I. And when this is done, let's do I plus plus. Will it work? No, it's not working. Um, okay, let me see how it is printing. 3, then 9, then 19, then 21, then should I skip this part? Of returning. You mean I should change it here only? Not. And I am guessing that it is. Can anyone try to form the tree out of it? 3 will come as a root node, then -1, left 2, left 9, right 8, right. It basically towards the left. Okay. Then 19, right? Then -7, left 21. It's only printing the right hand side part. Though all the elements which should be printed towards the left, it's skipping. And what's the reason?
Ma'am, how did you derive at this thing that only right hand side elements are coming? I mean, I'm not able to follow. For
You can
me,
try
look,
forming a tree out of this array.
yeah. So for me, it is left side. It is coming because 3 and I mean, assuming that the root
3
is
is the root. 3 is not on the left, right?
okay. 3 is the root. Okay. Okay. Let me form my own.
But it's wrong, I guess. Has the tree been formed correct? Let's traverse the tree. Like basically, instead of this is out. See, in the in order, -7, -1, 2 should come on the left hand side of the tree, then 3, 8, 9, 12, 17, 19. And it's correct, like tree formed has been correct. I don't know why it's we can't store it in the form of an array. Okay, cool. We'll see that thing later. That why the array is not getting formed. Our main focus should be what like how to form the post order out of this. You guys can look into that thing.
Yeah.
Okay, so post order we discussed two approaches, right? We didn't discuss the third approach. I told you guys to figure out the solution on your own first. Is it clear now?
Ma'am, one time just explain like with 3 or 4 elements, how pre and in will make into a post just with 3 elements or 4 elements like that. At this point of time, I'm a little bit confused.
This is an array. Okay. If I construct my tree out of this, 3 will come here, 7 will come here, -1, 8, 9, 6, and 2. Clear? If you form the pre-order of it, you will be getting it as 3, -1, 2, 7, 6, 8, and 9. If you try to form in order of it, it will look like
Ma'am,
-1.
ma'am, just one second. So the top one, the top line is pre-order array. That's a given array.
This is a pre-order array.
Okay.
Okay, that one was just an array.
Okay.
I
Just
formed a tree out of it. Okay, so 3
okay.
will come here, then will come 6, then 7, then 8, and then 9. So this indicates if 3 is here and the first element you're getting is 3, okay, this is your root. This one is your root. So the elements on the left side of it are going to form the left subtree, and this is going to form the right subtree. Clear? Is it clear?
I'm still processing, just thinking. Um, so given this, 1, 2.
You understand one thing, right? That if you are getting a root in the in order array, wherever your root is, all the elements on the left side of it are going to form the left subtree,
Okay.
and the remaining going to form the right subtree. It's basically like you get numbers from the pre-order and you get positions from the in order, that where to place that element.
Okay.
And remaining, if you want to do the analysis, you should give the time at your homework time, okay? Because
Yeah. Okay.
otherwise we are not able to move ahead in this session. Clear?
Yes.
Okay. Should I write the code for this? Okay, I know you guys can do it, but since it's been stretched so much, I'll just give the code to you guys for your reference. So right now, take your position equals to 0. Position means that initially you are moving from the pre-order from the 0th location, right? So take that. Now, via node, you will be given a pre-order array. In order array. Next, you will be given, you need to figure out where does the first element in the pre-order belongs in the in-order array, right? So you should be having some range in which you are looking for the elements. So that's what we take as a low variable, which will give you the lowest possible index where it can be found. And we will take a higher variable, which will tell you which is the highest possible index where your element can be found. Clear? It's basically like a binary search, because you know that in order array, sorry, not my bad. If at any point, I was about to say that it's kind of a binary search, but it's not, because it's never guaranteed that it's a binary search tree or is it a binary tree. So you can never assure that. Next, if at any point your range crosses each other, that is low becomes greater than high, at that point you need to exit or return. Now you will run a search function and find out the index of the number which was in the pre-order array in the in order. You need to find that index. So in this, you're gonna search you're gonna send here pre of position, whatever number from the pre-order array. You need to look it in the in order array. You will send your low variable in it, and you will send your high variable in it. Clear, everyone? Once you found out the index, what next thing you need to do? What is the next thing you need to do?
Ma'am, I'm just trying to understand, like when we pass pre with a position, we are trying to get the root. And then in and
Sorry, I didn't get you. Can you repeat?
yeah. So in the search, we are passing pre with a position.
Yeah.
That position is with an intention to get to the root. Or like position is in this right now in the first loop will be 0. So
Yeah.
it is at the root.
Yeah.
And then in is the given array. Low is the lowest element, high is the highest element. So
Low is the lowest index, high is the highest index.
okay.
Okay.
Okay. And so it will return me the given.
You didn't looked into this particular code yesterday, I mean. Did you?
Yeah, no.
That's the issue. See, if you're not practicing, it's fine. But at least if you're stuck on some problem, you should look into it for half an hour at least.
Yeah.
Okay. So all the confusions you have right now is because you have not even went through the code at least once in your day, and now you're having all the confusions. For trees, TP, and graph, I told you please give sufficient time to your studies.
Yeah, ma'am, go ahead. You can continue.
Okay, please. And once you found the index, you can form the node out of it, right? You found the index of your root node. You can form the node out of it. That is node root equals to new node. You can write anything here. You can either write pre of position, it will work, or you can write here in of index. Both the things will work out. Then you can go on making the left side of the tree. You can call here your function. You can pass here your pre-order array, in order array, low, and wherever your index you found, now it should be high, should be index minus 1. Are you getting it, guys? And your root dot right should be function pre in, it should be index plus 1, your low, and here it should be high. Once this is done, you can simply return your root. That means you're returning your tree. Once you got your root or tree, you can find out the post order in the similar fashion. You know how to do it, right? Clear, everyone? This is a way where you are forming the tree and then you are finding the post order. There is one more way where you need not find the tree or need not construct a tree. Do not construct the tree directly, print it. And guys, since I know that the sessions are going a little tough these days, and even I am finding the class is like bit very small. I started and only 1-2 questions are finished and it's done. So this weekend, Saturday probably, we can have an extra session where you can just discuss with me all your doubts. Okay. So I'm giving you you can say a class where you can come, you can ask me any doubt or any discussion, any practice you want to do. I'll just open a session for some time. Probably it should be in the morning. Okay, so I'll open it around 11. What say 11? Everyone is okay in the morning. Weekdays, no. Weekends. Weekdays, I'm not. Weekend. Only on Saturday, basically, not even on Sunday. Okay. So those who are okay, it's not a compulsory session. It's just, it's only for your doubts and all. I'll open the session at 11. I'll tell the sir to start the class at 11. And those who have doubts, discussions, you can discuss with me on Saturday. Okay. Because trees and all is little tough topic. So on weekend, we can discuss these doubts.
Ma'am, anytime before 11, I'm just curious, like 11 is 1:30 a.m. for me.
Oh, okay. Since it's a weekend, I was saying 11. I'm fine if everyone is okay with 9, probably. Is 9 okay with everyone? 9 in the morning? Yeah.
Yeah, me too.
Okay, then 9 will do that. So by directly printing, similarly, you will have a position array. See, right now what we are doing, we are separately constructing our tree. But what if we can directly print our post order? That's an interesting thing to do. Anyone is saying anything? If at any point a low is greater than high, return. The number which you will be searching here, like let's suppose from the pre-order, I'm imagining I'm searching for the first number, it's going to be the root node, right? But we don't know what should be its position in the post order array, right? Searching you all can do, right? There is no need for me to tell you guys how to search. I'm giving you the range also. You have a number, you have in order array, and you have low, you have high. You can do it, right? Yeah, low is 0 and high is array of length -1 for the first number. So okay. Now, once this position is done, you need to move to the next position. Then what happens in the post order? You call the left hand side, right? So you call your left hand side first. Then you call here your low and index plus 1. Sorry, index minus 1. And you can here print it. Are you guys getting it? It's the same, but here you can't print pre of position because every time I'm increasing the position, the only thing you can print here is in of index. The thing is, you searched for a number, which is the root node. Okay. You found like whatever number you're searching, you found it. Then according to the post order, you first go to the left hand side completely. Then you go to the right hand side completely. Correct? So every time you're searching a number, you are just keep on storing that in an index. You keep on storing in the stack, recursive stack, and then at the end you start printing them all. Clear? So the thing was, previously we were just every time storing it in the form of a root node, and then we were sending our tree completely, and then we were printing our post order separately. But here we are just using the trick of the post order and printing it directly over here. Are you guys getting it? Questions? Yes, what?
Yeah, I mean, I meant that it makes sense how we are going about.
Probably need to revisit once. Yes, you can. I just explained the codes today because it was getting stretched a lot. So just go through the codes now, and if you have still the doubts, we will just revisit it again. Clear, everyone? So today I won't be explaining the code for the length of path between the root nodes, but that will be discussed tomorrow. Clear? Okay. Okay then, so I will see you all tomorrow. Today I can't extend the class for a little long, so we'll see you all tomorrow. Bye-bye. And probably there are cases or chances that I may not be able to. Yeah, I know that I have not explained the optimized solution for the array problem. That I will tell you. And the thing is, probably I can't take the class tomorrow, most probably, but if I'll be able to take it, I'll just message. And if not, I'll message it around 7:30 probably in the group. Okay,
Okay,
guys. Okay.
thank you.
Thank you all.